Hello students, welcome back to our channel. Students, in this video we are going to study a very important topic from class 12th physics, wave optics, and this topic is Huygens principles. Let's start. There are two principles of Huygens which tell everything about the wave nature of the light. First law says that every point on a given wavefront acts as a source of new disturbances which are called secondary wavelets, which travel in all directions with the speed of light in the medium. Okay, what does this law say? To understand this law, we have to first understand the concept of wavefront, the meaning of wavefront. Wavefront is basically the continuous locus of all the points which are vibrating in the same phase. What is the meaning of this? Suppose this is a light source, right? And light waves are emerging from this light source in all directions like this. This is one wave. One wave in this direction also, in this direction also, and in this direction also, and in this direction also, and in between all these waves there will be infinite more waves, right? We have taken just 4-5 waves just to understand the concept of the wavefront. Okay, now let's take, suppose all these waves emerged from this source at suppose t equal to 0, right? So if we take a point on all these waves at suppose t equal to t1 time, so that point is here on this wave, suppose, so it will be on at this point, right? Because all the points, since all the waves have emerged from this source at the same time, so if we take any point on one wave at t equal to t1 time, then the same point on the other wave will be the corresponding point which is at the same position as this wave. So we have taken this point, for example, we have taken this point at the lowest point of the trough of this wave. So obviously if we take the same point at t equal to t1 on the second wave, it will be here, and on the third wave it will be here, on the fourth wave, fifth wave. So if we join all these points, so we will say that it is a surface. This is not a circle, it is a spherical surface, because these waves are emerging not only in this plane, but these waves are emerging in all the planes, right? So if we join the corresponding points of all those waves, we are going to get a surface, and the shape of that surface is circle. So we can say that all these points, this point, this point, this point, this point, this point, all these points are in the same phase because we have taken all those points at the same time. So they are, what is phase for a wave? Equation of a wave is a sine omega t plus phi, which is kx, right? So we have taken all these points up. Listen, जैसे this wave in time t1, if the velocity of this wave is v, then in time t1 the distance traveled by every wave is vt1. So this x is the distance traveled by every wave in time t1, which is vt1. So this is vt1, 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 right? So x for every wave is same. For every such wave, the value of x is same, and the value of k is also same, because k is wave number, which is 2 pi by lambda, and wavelength of every wave is same because they are same waves, and time for everyone is same, and omega is also same because omega is 2 pi by time period, and all these waves are same, so the time period is same. So they all have same phase if we keep x same and t same. So this point, this point, this point, this point, this point, we will say that all these points are in the same phase, right? So these points, surface touching these points which are in the same phase, that surface is called wave front. Clear? Okay, so first law gives some information of a traveling light wave in terms of wavefront. it says that every point on a given wavefront acts as a source of new disturbances which travel in all directions with the speed of light in the medium. Suppose this is a light source, right? And for this light source, let us say that this is a wavefront in the forward direction. We have just seen that the wavefront around a point source is spherical. So if we take just one part of the sphere, this will be a complete sphere, but we are taking just this part, right? So if we take one part of this sphere, then this law says that every point on this wavefront, acts as a source of new disturbances called secondary wavelets. We can assume that every point in a given wavefront is a source of light, right? But instead of light, we have used the term secondary wavelets. What does that mean? You just assume that secondary wavelets are emerging, small waves are emerging from all the points like this, right? And there will be more points between any two points, so we have taken just 4 or 5 points just to make you understand the concept, right? So these are the secondary wavelets which are traveling in all directions, right? So every point on a given wavefront acts as a source of new disturbances. For wave, we can use the word disturbance because wave is nothing but a disturbance in space. So that's why the term disturbance is used for it. So every point on a given wavefront acts as a source of small disturbances which are called secondary wavelets, right? Which travel in all directions, with the speed of light, right? These travel in all directions with the speed of light. Okay. Second law or second principle, this Huygens principles, collectively they are also called the wave theory of light because they are giving some information about the wave nature of light. Second principle says that a surface touching these secondary wavelets tangentially in forward direction at any instant forms a new wavefront at that instant, which is called the secondary wavefronts. Now if we draw an envelope or something, this for these secondary wavelets in forward direction only, right? In forward direction, in this direction only, not in backward direction. So a surface touching all these secondary wavelets tangentially in forward direction, a surface like this, a surface touching these secondary wavelets tangentially in forward direction at any instant gives a new wavefront at that instant, right? So this will be a new wavefront. A surface touching these secondary wavelets tangentially in forward direction at any instant gives a new wavefront at that instant, and that wavefront is called secondary wavefront. That wavefront is called secondary wavefront, right? And this wavefront was the first wavefront that we have considered. This is called the primary wavefront. Right? And these are called the secondary wavelets. Wavelets emerging from the primary wavefront are called the secondary wavelets. Right? So let's read it again. A surface touching these secondary wavelets tangentially in the forward direction, not in the backward direction, at any instant forms a new wavefront at that instant, and that is called secondary wavefront. So these two principles are very important to understand the wave nature of light, because using these principles we are going to prove the laws of reflection, the laws of refraction, and every other important property related to wave nature of light. So these are very important. Just prepare them carefully. I'll meet you in the next topic. Till then, all the very best.